based on the agenda. All right, everybody. I think we. So you want me to get going, Jenica?
Yes, I am going to turn my camera off and my microphone. By the way, maybe I should say a few words first. My name is Janneke van der Zee. I am the Managing Director at ITS Canada, and I am joined today by the Chairperson and CEO of ITS Canada as well. Her name is Shauna Boakes. And on behalf of Shauna and our Board of Directors, and of course of our Tech Hub Directors, a warm welcome to all. Today's first Tech Tuesday webinar, hosted by our Tech Hub, will be moderated by Nelson Melendez from City of Brampton. Nelson, over to you.
Thank you, Jenica. So yeah, we're very happy to see you all here, and you're we've been working hard in the background with the rest of the Tech Hub directors, myself, Jonathan Parent, and Bernard Tang. Trying to start giving some of these new ideas some shape, and this is the very first of this new format of webinars, and we're very excited to launch this. We're gonna, we're excited to continue to bring more value and information to the membership. And this is like a special day because we're launching this new format, and it's we can't wait to see what this turns into over the months ahead and years ahead. So thank you, thank you again for joining us on this very first Tech Tuesday. Let's get started on this new exciting journey of learning and sharing of information. We are, we want to keep the momentum from Ottawa going and going strong. So, and this is one of the very first major events that we have after Ottawa. So let's keep this momentum alive. Today, we're honored to have members of TTC and Brampton Transit, who will be telling us about their fleet electrification accomplishments and ongoing challenges. The sustainability and innovation teams for both TTC and Brampton Transit will be presenting on their respective transit electrification and transition to zero-emission buses. This is the first of many Tech Tuesdays, like we said, and but a special one because we thank you for being our first honor presenters, and thank you for your support. We need people like you to keep this information sharing going. So we are very thankful for you being here. So just to give you an idea, we're looking at about 30-minute presentation between the two agencies and 15 minutes of a question period time. And some of the topics that will be covered. Oh, I guess somebody's unmuted. Some of the topics that will be covered is e-bus transformation, challenges of electrifying bus fleets, charging strategies and standards, focus on technology and reliance, and challenges in terms of software applications that are needed to monitor e-buses, smart energy delivery from the grid and charging stations, predictive analysis, empirical data, and collection and analysis of bus charging information, route planning and scheduling and optimization. And this one is a favorite of mine, data mining, taking just dumb data that's sitting unused and turning it into actionable data. Energy as a service, and what is it? What is it, and why is it important to transit agencies? So just to summarize basically what you can expect from the presentations today. The presenters today are Mike Macas. Did I say it right, Mike? Chief Engineer, Bus Automotive Vehicle Engineering at TTC. Andrew Cowles, Manager of EV Systems at TTC. And our own from Brampton Transit, Gerald Jacob, Program Leader, Zero Emission Mobility, Brampton Transit. I will ask the presenters to tell us a little bit about yourself, and then we can get going with the presentations. So why don't we start with Mike Macas?
Sure. Good afternoon, everybody. Mike Macas. I'm the Chief Engineer of Bus and Automotive here at the TTC. This is my 17th year now here. Worked in a couple different capacities, starting at the ground as an engineering technologist, was a supervisor of quality and procedures for a while, and then was a manager of our vehicle reliability and quality assurance group, and I've been now the chief engineer since 2018. Prior to TTC, I spent almost 10 years in the automotive world, working for a Japanese OEM, specializing in chassis systems and product development. I'll pass it on to Andrew.
Sure. Can you hear me okay?
Yeah, we can hear you.
Good. My name is Andrew Kells. I'm actually the Chief Engineer for Renewable Energy Programs here at the TTC. So where Mike's team looks after the vehicles, I look after the fixed infrastructure, so chargers, the electrical distribution systems, battery energy storage. I'm going to get into solar, things like that. I'm an electrical engineer by I guess, an electrical engineer for almost 20 years, coming up on 5 years here at the TTC on the e-bus program. Before that, I was a consultant looking at large water wastewater systems and then large renewable systems. Yeah. Over to Gerald.
Yeah, thanks, Andrew and Mike. So my name is Gerald. I'm the program leader for Zero Emissions Mobility. I started my career in 2014. This is my 11th year working in the industry. I started my career as a co-op student with the TTC. From there, I actually moved to various departments in TTC. Last position was a foreperson for streetcar maintenance. Then I moved to the state of Brampton as a program leader, helping Brampton Transit to transition to zero-emission vehicles. And I'm working with this gentleman here, Nelson Melendez, just next door. So we have a lot of conversation and been very excited to have this Tech Tuesday because, again, this platform is going to open up a lot of doors into collaboration and maybe can solve a lot of issues in the transition to electric vehicles, especially when it comes to integration in the system. So Nelson, up to you.
Awesome. Thank you all for that introduction. And yeah, so I think we can get going. So we can load one of the would it be the presentation you sent me this morning, right, Gerald? So we can. Do you want me to just do we just give you presenter rights and you have it ready to go on your computer, or?
Yeah, I have it ready to go, so I can just share my screen and makes it easier.
Sounds good. Go for it then.
Awesome.
Thank you, Gerald.
Thank you. Nelson, you can see my screen? Everybody can see my screen?
Yep. Yeah, we can see your screen.
Awesome. So again, I'd like to thank ITS Canada for this opportunity to share our journey into the electrification and what are the next steps for the city of Brampton to achieve our goal to electrify our fleet. So we have a packed agenda today. Our team prepared a couple of slide decks. So who we are, what we did from the very beginning of the electric bus journey. What are we going to do with the SEB transition? What is our strategic vision or plan? What is energy as a service, which is a big question in the industry? And obviously, we're going to go into the fun and painful phase 1 trial and the lesson learned. So I'm going to start with who we are. So for those who don't know who we are the fastest growing transit provider in Canada. That's backed by, again, us being now the 3rd largest city by population, we're following only Toronto and Ottawa. So Brampton Transit has 2 facilities. We have our Sandalwood facility and our Clark facility, and we're currently on construction for our 3rd facility, and that should be completed in the next 2-3 years. Again, we have 1,600 full-time positions. We have 43 million ridership for 2024. 543 buses, which I'm gonna get into in the next slides. What makes us very unique is that our ridership recovery from the pandemic is ridiculous. A lot of, in comparison, Canada's average to recovery from transit ridership is around 10%. Our recovery is around 40%. So that makes our ridership grow significantly from pre-COVID level. Some of our routes are doubled in ridership in comparison to the fall of 2019, just prior to COVID and all the lockdowns. And again, 43 million rides for 2024. So our current fleet, currently we have 533. So that's 8 battery electric bus, 155 hybrid diesel electric, and 370 clean diesel buses. Currently, we have 10 Nova buses, new buses that are being commissioned, tested, and prepared for service, hopefully by November of this year. So how did we try these electric buses? So we tried these electric buses through the Pan-Canadian Electric Trial, bus electric trial, so the phase 1 trial, as we call it. So in 2021, with the help of QTRIC, so I don't know if for anybody that doesn't know QTRIC, so QTRIC is the Canadian Urban Transit Research and Innovation Consortium. It's a little bit of more handful, but they're the ones that kind of like lead the charge for the Canadian trial. It's the first in its kind in a sense where we we brought in a lot of OEMs, we brought in the government, and it's just a unique governance structure. So imagine various manufacturers coming in together for a cost, for interoperability, and to try if these electric buses really do work. This trial started on July 1st and just ended in December 31, 2023. We have 8 electric buses that we tried. 2 of them have a 76 kilowatt hour battery. 6 of them has 213, and we have 4 high-power chargers on routes, which I'm going to discuss in a later slide. So for the first one trial, we identified 2 routes. One is Sandalwood and one is Mount Pleasant Village. As you know, the Sandalwood route is a longer route. It's 59.2 kilometers RTD. Has 13 peak bus requirement, and it charges every time it goes to a charging station, which again I'm going to cover in the next couple of slides. The next one is our Mount Pleasant Village route. It's Route 26, again 11.2 kilometers, and there's 2 peak buses required on it. So our 2 smaller battery bus service this route for the whole day. During the phase 1 trial, we implemented 4 high-power chargers. 2 of them is our Mount Pleasant Village terminal. One of them is our Highway 50 in Queen location, and those chargers are made by ABB. Siemens one is located at our Sandalwood facility, also 450 kilowatt hour charger, sorry, for 50 kilowatts Siemens charger. And we have one in-depot charger during the trial made by ChargePoint. During the eBus trial, what we learned is that it doesn't, if it says 450 kilowatt hour, it's not really 450 kilowatt hour going into the bus. It's what the bus allows it to take. Battery capacity, if you have a 500 kilowatt hour battery capacity, it's not a 500 kilowatt hour capacity. It's stepped down to a 90%, 90% efficiency. Battery degradation, we have various data regarding battery degradation. Obviously, we're going to have the telematics tell us how the battery is performing. You have your sensitivity analysis. When it comes to battery electric bus, the first things that we have is range anxiety. So our operators are asking, can I reach that terminal if I only have X amount of charge? And we can't really tell them at the beginning because we don't know if that range is actually good. But based on the telematics, we can confidently tell the operators if you have 50% of SOC state of charge, you can go there, no problem, and you can charge at that point. Another factor that we factor in is temperature, how much the temperature affects the distance the buses can travel. Regenerative braking, when the bus brakes, it regenerates a certain amount of energy and needs to be optimized. So this phase 1 trial gave us an idea on what regen breaker is. And again, your driver behavior, how they drive, how they take turns and everything like that. It's all in the behavior of the driver and see how much efficiency there is. So the key objective of our phase 1 trial is full interoperability. We have to address that. Reason being is if we don't have interoperability between chargers or buses, it's going to be a very expensive journey. Imagine buying a Nova bus and it can only have a Nova charger. Then you have a Flyer bus, then you can only have a Flyer charger. In that regard, whatever charger you have, it can charge any bus that you purchase, and that's part of that. That's part of that process of the interoperability. Again, we have the huge success. We have a unique governance structure. A bunch of manufacturers come together on a table, trying to achieve a common goal. And again, this trial was during COVID. I know it's a little bit after like the lockouts and everything, but it's during COVID. It was delivered on time and on budget. Our predicted efficiencies are actually what we obtained, which is really good. Just basically confirm our assumptions. Our BEB, we confirmed that it has the highest greenhouse gas reduction. During the phase 1 trial, just high level, total efficiency that we have from our 8 buses is 1.6, which is close to what we predicted initially. It's actually performed better than what we predicted initially. And that data has again been gathered from July 1st, 2021 till December 31st, 2023. Our 4 chargers, so for Mount Pleasant Village to Highway 15 Queen, total energy transferred is 1.15 million kilowatt hours. Average duration of charge is 10 minutes. Average power transfer is 279.75. So for anybody that likes to analyze data, this is the data. If you want to ask questions, please do ask us questions during the Q&A. After that phase 1 trial, we completed our feasibility study. We went to our city council in May 2024. We presented what we call a zero-emission bus implementation strategy and rollout. And that's in partnership with QTREC. It's a very extensive study. We figured out what's the optimized route, how to optimize our routes, what's the best transition, what buses to use, what charging infrastructure do we need. And this strategy was approved by council in 2024 to basically start our journey to full electrification at the earliest of 2041. We're looking at, like, we did our GHG estimation on the reduction. So short term, which is 2025, 2030, medium term, 2031 to 2035, and again, your long term for 2036 and 2050. With that being said, this is what we're planning to do in the future. So as you already know, our phase 1 trial get completed in December 2023. We're looking at now of phases 2 and 3. We want to do a fuel cell electric bus trial. Again, we're still in discussion regarding the matter. We want to convert a diesel bus to a battery electric bus. Again, it's a trial. If we don't try it, we won't know if it actually works. We're in the design process of our retrofits for our Sandalwood and Clark facility. And based from the strategy that QTREC identified, we're looking at a 66% battery and a fuel cell of 34%. And again, additional on-street charge. So our strategic plan and vision, there was 3 scenarios that QTREC looked at. We have your scenario 1, scenario 2, and scenario 3. We ended up with scenario 3, which is a mixed fleet of battery electric bus and hydrogen. We're going to be rebaselining this strategy in 5 years. Maybe there's a new technology that emerges. Maybe there's an improvement in technology. And we're going to see if we have to change our strategy or we keep going on our strategy. The strategy is scenario 3 predicted a 95% operational GHG reduction, and it's the least amount of vehicles that's going to be needed for our full transition. Out of that strategy, we figured out that this is going to be a complex process. It's going to cost a lot of money. We don't know what the market landscape is. There's a lot of unknowns in this matter. We're not an expert per se of doing electrification. Our expertise is fixing a bus, putting them in service, and making sure that everybody in Brampton gets into their location on time and safely. So what we asked QTREC to do is find an energy as a service solution. So QTREC did a market survey and identified what energy as a service is. So energy as a service is going to be doing the infrastructure that we need to transition to full electric vehicles. That full transition includes hydrogen and battery electric buses. They're going to take the complexity out because what we envision our partner to be is somebody that's been in the industry for a long time, and they have the knowledge and the know-how on how to do this process. In June 15, 2025, we announced our partnership with Sonobe. Sonobe is a UK-based company. They're going to be doing our infrastructure, what on the next slide is saying. So Electra, which is our utility provider in Brampton, we're still going to supply us the electricity. Then Sonobe is responsible for the substation, the switch gears, battery storage, generators, solar, and obviously hydrogen in the future, and their energy management. And we are going to be responsible for dispatching the bus. So this is our energy as a service model. Sorry. On this energy as a service model, we are looking forward for this journey. We're in the design phases now. I don't have a lot to share at the moment, but when the time comes, I'm pretty sure you're going to see more about Brampton's energy as a service journey. My last part is just learnings, lessons learned. It's transitioning to BEVs with all the data that we have. It's very complex. We require a 10-minute charge time per bus extra on our charging on our Route 23, so that you have to factor it in to your OPEX. So more staff, you have increased your labor hours, your infrastructure is very complex. Your station power versus what the BEV can take. You have your higher capex and OPEX regarding versus your depot chargers, and again your unplanned downtime. En route charging is a big thing. That was probably what we identified the most difficult part of the whole process. So what we ended up doing is we did en route charging, and we figured out that if we can do this, we can do everything else. Lessons learned. One of our en route charging is exposed to a lot of elements. So which basically, if you can see here, there's an angle, and it actually there's a lot of when a truck passes by, there's a lot of turbulence on the vehicle, so there's an arcing involved in there. So another factor to consider there. And again, it's very complex. Like if you can see the map here, this is what we have to do to install one of our chargers. We have to move it around and like install all the conduits around it. So that's why we have an energy as a service partner. And last part, again, expect the unexpected. You have water, electricity and water, they're really good together. You have your mouse in here. By the way, this mouse they have electrical engineering degrees because we have 3 cables, sets of cables with full redundancies, and they bite all of them. So our cable charger went down. So we ended up no pantograph charger for that specific for a good 3 weeks of time. And again, expect the unexpected. But again, we're more than happy to answer any question that anyone will have. That's it for me. I'm gonna pass it to Nelson. Thank you.
Awesome. Thank you, Gerald. That was great. I think we should maybe leave all questions to the end, and let's move on to Mike's and Andrew's presentations, and that way they get enough time to do their presentations, and then we will. So if you got questions for Gerald, save them up, and then we can ask them at the end. So Mike and Andrew, the floor is yours.
Okay. So why is TTC electrifying our bus fleet? So there's a couple of driving forces here. So internationally and nationally, there's targets from the UN Sustainable Development Goals to reduce greenhouse gases by 43% from 2010 baseline and by 2030, and to net zero by 2050. The C40 fossil fuel street declaration in 2017 to procure only zero emissions buses from 2025 onwards, and the Canadian Net Zero Emissions Accountability Act in 2021, and Canada's commitment to achieve net zero GHG emissions by 2050. So locally in the State of Toronto, has a transformed TO target in 2021, and that's the transition bus and non-revenue fleets to net zero by 50% by 2030 and 100% by 2040, and then achieve net zero citywide GHG emissions by 2040. And then the City of Toronto Sustainable City Fleets Plan in 2023 to transition city-owned fleets to zero emissions, 20% by 2025, 50% by 2030, and 100% by 2040. So just looking at our fleet composition, our fleet, just so everyone's aware, we have a fleet of roughly 2,100 buses at the moment. Of those 2,100 buses, we have 60 electric buses that were procured in 2019 that make part of our pilot fleet that we started this program with. And we have about 140 some odd buses from our kind of second order that we're taking delivery right now. It's an order for 340 electric buses. Those will all be here by Q1 of next year. We're at about 150 or so delivered. And then we have a roughly around 600 or so hybrid electric buses, with then the remaining fleet being primarily diesel. So as you can see from the charts here, our emissions, Scope 1 and Scope 2 emissions for the TTC are predominantly from our diesel buses, so they make up 80% of our GHG footprint. So looking at our path to zero emissions, so up until the 80s, we were running two-stroke diesels, our old GM buses that everybody loved and still love today. And then we switched up to trolley buses in the 1990s. Those buses eventually were replaced by compressed natural gas buses in the late 90s. And then towards the early 2000s, we moved to conventional diesel again and only bought diesel up until the mid 2000s, where we bought our first generation hybrid bus. Those first generation hybrid buses had a lot of issues early on, and so we got some cold feet, and we reverted back to our tried and proven diesel buses. Although in 2010, these were called clean diesel buses because they had all kinds of exhaust after treatment systems on board. Move on to 2018, we went back to hybrid buses, looking at the second generation buses, and these have actually performed really well for us from a reliability and availability standpoint, and they've definitely reduced our emissions footprint from a diesel by almost half. And then finally in 2019, we bought our first electric buses. That's, as I mentioned earlier, we bought 60 buses from 3 different vendors, from Proterra, BYD, and New Flyer. Those 3 OEMs were the only OEMs at that time that offered a long-range depot charged bus configuration, so that's what we went with. Fast forward today, we put about almost 7 million kilometers on that particular fleet, and all our lessons learned from that fleet's kind of translated into this current order that we're taking delivery of for 340. So by the end of Q1, we'll have a fleet of 400 electric buses. So looking at our targets, we're on track right now for 20% in 2025 to be zero emissions. We're on track by 2030 to have half of our fleet to be zero emissions, and we're on track to be fully zero emission fleet by 2040. So electrifying transit is a wicked problem. So there's complex and interdependent, require coordination across utilities, OEMs, unions, and the agency itself. There's high uncertainty. So the technology itself, battery life, charging standards, supply chains that are always evolving, infrastructure challenges, grid upgrades, space constraints, operation disruptions while you're making all these changes. Operational trade-offs, so scheduling is different. We have range constraints. We have to account for charging downtime, and we need to change our maintenance practices. Financial pressures, so there's high upfront capital costs for this technology, and there's uncertain long-term savings and government grants. And then finally, workforce transition, so new training, new safety standards, new skills for operators, maintainers, and first responders. So looking at intelligent transportation systems on board our buses, there's quite a few. So you have our automatic vehicle locator. So that's GPS tracking to know where the bus is real time. We have our computer-aided dispatch, where we assign, monitor, and manage buses dynamically. We have automatic passenger counters to track our ridership. We have passenger info systems for real-time arrival info, so that's like your destination signs. Safety systems, you have cameras, driver assistance systems on board, and collision warning systems, which we're currently evaluating at this time. Automated fare collection, so smart card, contactless fares. Bus telematics, so we can monitor vehicle health and battery performance. And then energy management systems to manage chargers and optimize energy costs. So what can we do with that information? Firstly, the technology maturation with ITS. These buses, although they've been around since 2015, let's say, when the first electric buses arrived in the market, this technology is still evolving. It's still somewhat immature, and a lot of the troubleshooting can be very complex. And so telematic data from the bus is an absolute must in order to expedite the maturation of this technology. So what you see on the screen here is kind of some samples. On the left is really a sample of the dashboard that we see with the telematics we have on board our buses, so you can track where the bus is traveling, speeds, energy consumption, and then some statistics on overall energy consumption rates historically, fault codes, things of that nature. And on the right, it's kind of an example of a problem we experienced on a bus and some of the analytics that we can perform by retrieving data from a couple of days, sometimes weeks ago, that we can retrieve signals and then try to better understand what's causing the problem, what the root cause is. And this data has been indispensable for both TTC and also bus OEMs as they're trying to resolve some early issues as these products arrive on site. Secondly is we need this data for operational planning. So again, there's a change now in the way we manage buses and the way we dispatch them. We have to make data-driven decisions now. We have millions of data points. Like I mentioned, we have almost 7 million kilometers of in-service data from our pilot fleet. So we're leveraging that to make decisions on how to operate these buses, determine the range capability of these buses. As you can see the plot on the side, the range capability of these buses vary depending on seasonal impacts with ambient temperature. What you see there, the blue dots, is basically a scatter of all the data. So as you can see, it's not as simple as just picking a number or picking a range. The range varies. Range is influenced by ambient temperature, by precipitation, by routes, duty cycles, and the average speeds of those routes. So we're leveraging all this information to make decisions on how to dispatch these buses. And this is an iterative process where we take data, we set a point for a dispatch range, and we go back and check. And we keep on adjusting those points to maximize utilization of these buses and ensuring that they're out in service and putting as much mileage on them as possible so we can continue to learn from them and ensure our experiences and learnings with the industry. So another thing from an operations standpoint that we need a lot of these IT systems for is to manage the state of charge of these buses. So what you see on the screen is kind of our high-level description of the logic that we use. We set up alerts with our telematics, and we have our first alert at 12%. Which roughly gives you about 20, 25 kilometers of range remaining. And at that point, it really kind of prompts a dialogue between transit control and the operator to understand how much longer they have left on their route, and does the bus have enough charge on board to finish that service, or if we have to plan for a change off. And then the second alert set at 7% state of charge, and that really leaves us with about 10 to 15 kilometers of range, and that's really meant to just have enough power on board the bus to deadhead back. So if the bus is still in service and carrying passengers at that point, we would grant them a change off so they can finish their day of service, and we would bring this bus back on its own power. Happy to say that since 2019, we've only ever had one bus that we've left stranded due to low state of charge. So the system's working, and on the right side is basically a snippet from our SOP. There's some flow charts that transit control uses to guide them in the dialogue that they have with the operator. Pass it on to Andrew.
All right. There, move the laptop. Okay, so Mike showed you the EMS as a single block. We'll break it down a little bit here. The change to electric buses also comes alongside large-scale changes in how electricity is used and managed, especially at larger consumers like transit agencies. So on the left, you see a variety of sources of power that we either currently have on our site or we're in the process of rolling out. We have on the right a number of chargers. We can have hundreds of chargers on a single site. We can be running 200, 300 buses out of a single site, and all of that is connected by a large distribution system and then managed by the energy management system. One of the nice things about modern electrical systems is we can control pretty much everything in here, from opening and closing of switches to whether our storage systems are drawing or supplying energy to how much our generators might be using, and we can also control our load through our chargers, which means we need a lot of metering. So from an ITS perspective, there's a lot of data happening here and a lot of control possible. That all kind of gets rolled up into a much larger ecosystem. So that was the physical assets, most of which are on the left here. We also have the things along the bottom, like we may be taking energy pricing data or program data from the IESO to participate in the larger energy markets in the province. We need basic things like weather forecasting for predicting range and things. We might be talking to our building automation systems. We're getting, fire alarm systems. All of this are kind of even talking to the network systems to know if the networks are up. And then we've got all on the right a lot of the same systems that Mike showed around the bus. So your telematics, where your vehicles are, what they're assigned to do, how many people are on them, what the routes look like. All of that comes together into, arguably all of this becomes part of the energy management system. Really, all we're trying to do with all of that is two key things, which is optimize our power demand, because we know we have reasonable indications this can reduce our power draw for a full bus garage from maybe 18 megawatts to 12 megawatts, so a pretty profound reduction in power. And also maximize our bus utilization, especially while we're running a mix of fleet. We want to put as many miles as we can on the electric bus fleet, even in light of we have some power limitations at some of our early sites. So we want to make sure we can utilize that utilize those buses to the best of their ability. So far, the items in green are what we've managed to accomplish. So we're taking there's obviously a very large problem, and it's not a solution you can just buy off the shelf today. So we're taking a very staged approach to this. Items you see in green are operating, they're systems that are interconnected today. So we have control over our chargers, we can monitor our power use through our meters. We know where the buses are, we're drawing that information. And sort of we have our single sign-on stuff with our identity and access management. The items in yellow are the things that we're currently getting to the test phase on. We're doing early stage testing on the rest of that, so that we then start to have more control over our site power use, and we link the energy management system with some of the other systems already in use that tell us where our vehicles are, what they're being used for. So to start to join those two complex systems together. And so far, we find it's generally feasible, but obviously, as I mentioned, this is something that doesn't really exist off the shelf. So we're from an ITS standpoint, there's a lot of data interchange issues. Obviously, there's no standard interface formats for some of these data types as you try to join these two large systems together. Sometimes there is a standard interface, but it lacks features. A good example is it's nearly impossible to get a vehicle unique identifier through a level 2 charger, the kind of charger you might have at home. We use those for some of our smaller vehicles, like paratransit vehicles. It won't tell you what vehicle is connected. So even where you have a standard interface, it doesn't always have all the features you need. So you need to develop workarounds. You're writing custom APIs for every single pair of systems you need to connect. Even when you have an API and you have a standard interface, sometimes it doesn't work when you try it because you're the first person to try it. So all the kind of standard things you'd expect on a new sort of endeavor. Plus, also we run into data ownership, IP rights, security concerns as well. Right? These are systems that are they're targets for hackers. So our security is obviously a high. It's pretty high stakes. We're looking at if you were to hack a single bus garage, tens of thousands of people rely on that bus garage to put out service every day. So cybersecurity is obviously a big issue. And then folks don't want to give up their data ownership. Everyone wants a piece of this pie. So sometimes just the contractual issues create issues. All this is just resulting in extra time and extra costs. So we're hoping that some of those systems get addressed as we work on this. The image on the right is just a snapshot from last night of our power control in action. Kind of comes up and hits that yellow limit line at the end. But we're able to see which charger is drawing which amount of power. That's all the colored lines underneath, as well as the system total load. And we can see which buses are charging from which chargers. We can see it bounce back and forth between the buses. So we do have quite a high degree of visibility on the system, as well as control, even with kind of the limited green boxes I showed you earlier. That's still a fair amount of work just to get to that stage. Some of the lessons that we've learned, especially with regard to the data stuff, starting simple is definitely the way to go. If you can start with monitoring, then you can prove out that the system is inherently reliable. You start with limited controls of things as you work towards full control, and then you optimize. We do that both on individual functions and with individual pieces of equipment, as well as the system as a whole. So baby steps is the way we're taking a lot of small steps, and it's very easy to manage. Testing is obviously very important, especially starting with very simple tests just to prove basic connections and capabilities. We don't want to go to sort of full-scale tests of algorithms if we don't know can you start a charger? Can you stop a charger? You need to start basic and build up, especially as we were in the early stages of this transition. And then one of the big lessons we learned is starting with simple, clear descriptions so that everybody is on board with what the system is going to do, developers understand what we need from it as transit agency people. And we understand what the developer is writing, so we exchange languages. We exchange the requirements in very simple language, typically things like user stories, stuff like that from Agile. And then just a little bit to tie this back to energy as a system as well. So we do have a charging system supplier. So we are in sort of an energy as a systems model, and so we have a service provider that's taking on a lot of that complexity and integration risk. Which is nice. It doesn't relieve all of the burden from kind of the operator. We still need to make sure that we understand what we're trying to optimize, and different optimizations work against each other. We need to that data ownership and rights issue is important to make sure you've got nailed down first. You want to make sure you've got ownership of your data. Milestones and dates, obviously pretty key. But also approaching it in an agile fashion. So tie off those milestones and dates with, you need something by that date. Kind of your minimum viable product concept from agile is helpful here. Don't try to push for everything by that date, or it's always going to slide. Like, just make sure you're making progress one date at a time, and be a little bit more flexible than typically we are in procurement. Right, that's it from us. Let's computer back over to Mike.
Awesome. Thank you for that great presentation, Mike and Andrew. So we hit the 45-minute mark, and I just want to, if Mike, Andrew, and Gerald are okay to keep going until 1, we can open up the floor for questions. I don't know what your schedules are like. Do we have another 10 minutes?
Yeah, we can stick around.
Awesome, great. Gerald, you're good?
Yeah, I have no issues, Nelson.
Cool. Okay, so there is a question in the chat, and so I encourage anybody that doesn't want to speak up and just wants to type it up. They can type up the question in the chat, and I'll ask the question, or you can also unmute and ask your question. But maybe put up your hand so we know that you will be speaking. So I got a question from Bernard. He says, in your opinion, is there a future for ERS, electric road systems, become a component of an electrified transit agency's infrastructure? Is there justification for wireless charging from a cost or schedule adherence perspective? It wasn't directed at anybody in specific, so I don't know if any one of you three gentlemen wants to take that question.
I mean, I can start. It's a really good question. And it's something that we ask ourselves on what the options are, considering that the reality is that the energy density of batteries today that are used in our buses is such that an electric bus is not a true one-to-one replacement of a diesel bus from a range standpoint, because it doesn't have the same range as a diesel bus. And so we kind of often ask ourselves, well, okay, we're banking on battery technology evolving over time, and it certainly has over the last few years that we've been, procuring buses and operating ours. And just for example, our Generation 1 buses had a range roughly of 180 kilometers. And the buses that we are receiving now have a range of around between 240 to 250 kilometers. So there's already been an uptick in energy density since 2019 to 2024, let's say, so over a 5-year period. And we expect there to be anywhere between like a 10% increase year over year, roughly. Time will tell. But if we don't get to the point of a true one-to-one replacement because the range simply doesn't get there, there's a couple things that we can do. One, that we're working with our service planning department to rejig a lot of our service to try to bring some of those blocks of service into that sweet spot for range, so we could put these buses out there. But there might be some runs that are just really too long for an electric bus, and that's when we have to start looking at other options. One being opportunity charging. Now, this electric road systems, I presume this is more so. I've seen some of this before, where you have the buses actually driving down the road and being charged. I think that's a really, really good concept. But I think you look at some agencies, and perhaps why a lot of agencies aren't adopting like a true electric bus being a trolley bus. I know Andrew loves trolley buses. We once had trolley buses too, but the problem is the maintenance of all the infrastructure required. And so that kind of becomes a big question is, okay, so what does this ERS look like? What kind of modifications do you have to make to the roadway? How do you maintain that? And what is the cost of that? At the end of the day, versus looking at, okay, you have buses that don't have the range that you need. Okay, well, maybe you need to buy a couple extra buses. Maybe your fleet size needs to increase by 2 or 3%. And now you can satisfy your service versus introducing some complex charging system that's on the roadway that now you have to maintain and can probably be very expensive. So I think this is tough because this technology, we've seen it, images of it. There's concepts out there, but I don't think anybody's really commercialized this yet. So a lot of challenges out there and a lot of options and ways to resolve this. I don't know, Andrew, if you want to add to that.
Yeah, and the losses with any of the wireless systems are likely to be an issue. Where like at full electrification, we would need something on the order of 1/3 of a terawatt hour of electricity a year. So if you're losing an extra 5% on that, that's a lot of loss. it's in some ways feels like it is a solution looking for a problem, perhaps, because we have systems that work today that by the time that is developed, it's likely that we'll have enough conventional systems that the cost to change over may not be worth it. And it also puts things, as Mike mentioned, stuff in the roadway is outside of our control. Either we then end up maintaining the road like we do with streetcar infrastructure, which adds to the cost of service and unfairly puts that on our books versus on the public books, or we're at the risk of a partner who may not have the same goals in mind as we do. So there's a lot of risk with, especially in-road charging.
Especially in a city like Toronto, right? Like now you get so many other stakeholders being affected and somewhat involved in the operation and maintenance of these systems. So you answered one. I love trolley buses too, and I was gonna you answered my question. It was a challenge with the maintenance of the infrastructure, I'm assuming, because I remember running I often thought about that. Like I remember riding in trolley buses here in Hamilton, and we had an electric solution already, but it went away. So it almost felt like we went backwards. But it sounds like the maintenance of the infrastructure was what did the trolley buses in. Would that be accurate?
And the budgeting around the maintenance of the systems, because it's one of those kind of things that gets deferred by successive governments, and then you end up with a maintenance backlog, and then it gets pulled out because the cost to bring it back up to standard is now an enormous cost to bring it back up to the standard you needed to operate at. It's not because you've deferred the maintenance for decades.
Okay, cool. That's really interesting information. That's good. Yeah, so I do love trolley buses too. But so I don't see any more questions in the chat. Anybody has any questions? Please feel free to ask. But while you're thinking about any other questions, I'm going to ask a question. Battery runaway. And also I'm directing. I heard some on our side on the Brampton transit side, but I'd like to hear what the TTC is doing. What systems are you putting in place or procedures in place to or how are you thinking about using data in the future to monitor battery runaway problems. And for those that don't know, I mean, in the call, battery runaway is and you guys know more about it than me, but batteries can, it's a thermal issue where batteries can transfer heat to a different to the battery packs and eventually catch fire, and it's kind of a chain reaction, right? Am I describing it correct, Mike, Andrew, and Gerald?
Yeah, so I'll start with that, and also you got it. So it's battery. It's a chemical composition, right? So it can go, like, when it goes on fire, it will keep on going, and that's gonna be the thermal runaway, and it's just gonna keep on going. And like the mitigation strategy for this is like put lots of water on it. We have a committee. We're in discussion with this. It's a thermal events committee. It's actually led by a former Brampton employee. He moved to Metrolinx, and there's a lot of good information in there. And like for now, the mitigation strategies put water in there. And as you already know from Brampton Transit, we have an SOP on what to do if there's a thermal runaway, right? But that's going to be part of planning when you're retrofitting your facility, because they're developing a standard now. I don't know how that standard going to look like later on. But if the standard looks like, oh, you need to have X amount of liters of water for your sprinkler system, right? So that's something that you need to be involved. You need to kind of like project right away, because you can't be caught like, oh no, we have to upgrade our system now, or we have to upgrade our water, right? Because there's a lot of involved process, especially for like Brampton. I don't know how it works in the Toronto area, but we have to involve the Peel region, right? We have to involve the Peel region, and that can take a lot of time. And if your structure is already built, we're retrofitting our Sandalwood facility. If a structure is already built, then we need to dig more. That adds to cost, adds to time, adds to complexity, right? So there's a bunch of things in there. So I'm going to pass it to the TTC guys, TTC team.
So I can maybe provide some more info on bus before I pass it on to Andrew to talk about infrastructure. But on the bus side, Gerald's right. There is a thermal events task force that's through the Tuesday Sept committee, and that task force has been put now over 2 years, I think. And we've been working on some developing guidelines to provide some guidance to other agencies that are just adopting this technology, and really kind of the premise of what's being recommended is kind of erring on the side of caution. You don't know what you don't know. And so today, the approach that we're recommending is super cautious. So we are leveraging the telematics on board our buses, much like we monitor state of charge. We're also monitoring battery temperatures. And so we've adopted a 3-stage alert process. And so stage 1 alert is essentially triggered when the battery temperatures exceed more than 10% of its upper kind of normal operating limit. And that's kind of the first alert to say that here, something abnormal, something wrong with this bus, someone should maybe look into it. We expect that 99.9999% of the times it's just a fault with the battery thermal management system, either a fan down or a pump that's not working or something along those lines. Then we have a second alert that's at roughly about 85 degrees, which at that point now it's like, okay, something's not normal here. This temperature is no longer something to do with the BTMS. It's maybe something else, maybe the start, the earliest indication of a potential thermal event. And at that point, we're instructing those buses to be, parked in a quarantine zone to evacuate any passengers you have, and really monitor to see if it truly is an event or not. And then the third stage is really at over 100 degrees Fahrenheit, which we now know this is really the start of a thermal event. At that point, you're calling in the fire department and you're planning for the worst. So a lot of this really is, really hinges around monitoring of these signals and making these decisions on whether or not it is a true event or not. I can say we haven't had a true event, knock on wood. We've had many false alarms, probably 7 or 8 now, a lot of them being sensor issues with thermistors faulty, open circuit, but for a split second. So you can look at the data and you'll see that the temperature is hovering around 35 degrees for battery, and all of a sudden it spikes up to 120 and for 500 milliseconds, and then it comes back to 35 degrees. That sets off all our alerts. Everybody panics. But then when you look at the data, you realize, it's a false alarm. It's a bad sensor. You put that bus to the side and you arrange for a repair, a replacement of that sensor. So that's kind of how we're managing it now. The guidelines that we were released, kind of our first draft. The final draft will be released in probably the next 2 or 3 weeks. We're going to publish it. And really that guidelines kind of goes through this logic to thinking, kind of recommendations on quarantine zones, to establish quarantine zones to park a bus that you think might be undergoing a thermal event, to make sure that you don't have any consequential damage to surrounding assets or buildings. And then we have kind of like post thermal event, what you need to do to that facility now in order to deem it okay to return to service. Because obviously if there is an event, we're going to miss service, but we're going to be anxious to kind of resume services. And so we need to know, what do you need to check? What do you need to do? What do you need to clean? What measurements do you need to take in order to say that the site is safe for our employees to return to work and to resume operations? I'll pass it to Andrew.
Yeah, I mean, a lot of I guess one thing to keep in mind also is it's a relatively rare occurrence versus the constant threat of automotive exhaust, which is not good for people under any circumstance. It's important that these systems are managed by people like us, by the automotive industry, to make sure that these rare events don't become more frequent and derail what's generally a good thing. The thermal runaway is an inherent risk of the technology, but it's getting pretty well managed, especially in the light duty arena. There's more and more stories of things like Teslas catching fire, and it doesn't spread to the battery pack. So they're getting very good at building very survivable packs. And you're going to have a thermal runaway event, but they're getting to the point where that can be that the packs are designed so well that just doesn't propagate. Right? You have one cell going to thermal runaway, it burns itself out. That's a maintenance problem, not an insurance problem. And so that's the way the industry seems to be heading. There's just an awful lot of money tied up in lithium-ion batteries, and the overall uses, the benefits to society far outweigh these risks, and they're being managed fairly well. But it is an important thing to be aware of and to manage, to making sure your sprinklers are right, you've got detection, you've got the procedures, that sort of stuff.
That's awesome. Yeah, that's great. Thank you for that. Those great answers. Yeah, and what I was thinking in my head as we think about all those telematics that all that data you want to mine and make it actionable, this is a good one, right? Because you can get some early warnings, and it sounds like that's exactly what you're doing already. You got that 3-stage warning. So, and it's good to know that it's a very rare event too. So thanks for those answers. I don't see any more questions in the chat. We're gonna go and ask one more time, once, twice, and got a question for Janica.
Yeah,
Go
there
ahead,
is
Janica.
Scott in the chat. He was wondering, are wondering if the presentations can be shared. So for those, right, So I was just wondering if maybe that can be done offline, if Mike and Gerald would be okay sharing the presentations in PDF format, or?
Yep, we can accommodate that.
Yeah, absolutely no issues with that.
Awesome. Good
Thank you
stuff.
very much.
So I think we're going to call it a wrap. It's almost 1 p.m. So just want to thank again the presenters for those great presentations and for participating on our launch Tech Tuesday. Thank you to the membership for attending and being part of this journey. Any questions that you have for us or even the presenters, we can pass on any questions to the presenters. You can reach us at techhub@itscanada.ca, techhub@itscanada.ca, and that goes for not just for questions for this presentation, but any questions, suggestions that you may have for the Tech Hub leadership, myself, Jonathan Parent, and Bernard Tang. And also, just let's get involved and let's keep the momentum going. If you have something innovative, you're looking to volunteer or an opportunity to present at an upcoming Tech Tuesday, please reach out to us at the same email address, techhub@itscanada.ca. We're going to be looking for more presenters down the road as we continue doing our Tech Tuesdays throughout the year. So thank you again. And I hope you enjoyed the presentations and that you walk away with some great knowledge here. And thank you again, TTC and Brampton Transit for participating. Janica, any final words?
No, thank you, Nelson, for getting things organized for today. Very, very much appreciate the efforts. Thanks, everybody. See you at our next Tech Tuesday webinar.
Thank you. Take care.
Cheers.
Take care, everybody.